This project is about client-server application that works like a name server, similar to how the internet finds website addresses. Our team made a small version of DNS, which is the system that runs website names into IP addresses so computers can find websites. We used Java socket programming to create this. Imagine the internet like a big city. Websites have street addresses. They called it IP addresses, but instead of remembering numbers like 142.250.182.14, we just type google.com. There are two types of computers in our project: client server and name server. Like someone asks for direction, it is a type of client, but a server answers it as like a directory service that knows addresses. Whenever the client sends a domain name like google.com, the server replies it with IP addresses. If the name doesn't exist, it replies with a pop-up named as domain not found. It is also the same way the real world DNS idea is in a simple way, but when the client server can't find the domain, it always gives a pop-up of domain not found. The main goal was to build a mini DNS system in Java. We wanted to understand that how clients and servers talk using sockets, learn how websites are converted to IP addresses, practice real networks programming concepts. The server stores some website IP pairs. The client stores some website IP pairs. The client sends a website name and server replies with a maintaining or matching IP. The this follows the client server communication model.
To the coding of our lab, which shows the step-by-step logic of both the server and the client sides. We have implemented this project using Java socket programming, which allows two programs to communicate over the network. Now let's go towards the name server programming. This program starts by initializing the port number 5000, which will be used to listen for the client connections. Next, we have created a hash map called DNS table, which stores all the IP addresses. Then a server socket object is created on port number 5000 to start listening for the client request. Inside the infinite loop, the server keeps running continuously to accept multiple client connections, one after the another. Once a client connects, the server reads the domain name sent by the client using the input string. It searches the domain name in the DNS table. If domain is found, the server sends the matching IP address, and if not found, it sends the message domain not found. After sending the response, the server closes the client connection and waits for the next one. This is how the name server continuously runs and acts like a real DNS, receiving domain queries and responding with their IP addresses. Now, let's move on to the client programming. The client connects to the server running at the local host on port number 5000 using a socket object. Once connected, it displays a message connected to the server. The client then asks the user to enter a domain name like google.com. It sends the domain name to the server through an output string. The client then waits for the server's response. Once it receives the IP address or the error message, it displays it to the console. Finally, it closes the connection. This flow clearly shows the client and the server communication in the real time, one sending the request and other replying with the correct data. Now, this slide shows the actual output of the project and explains how our implementation works in the real time. This project is implemented in two Java files, nameserver.java and nameclient.java. We first run the server program. It prints name server started on port number 5000. This means the server is ready to accept the client connection. Then we run the client program. It connects to the server and prints connected to the name server at localhost 5000. The user is then asked to enter the domain name To resolve, the client enters the domain name and the server responds with the corresponding IP address.
Let's move on to the advantages and applications of a system. It gives us an hands-on understanding of how the domain name system works behind every website we open. Helps in learning real-time network communication, socket programming, and data exchange. Shows how a client-server architecture forms the backbone of all the web systems. It is lightweight, easy to test, and can be expanded into more complex projects. Encourages teamwork and modular design, since both the client and servers are developed separately but must work together perfectly. The applications are. It forms the base of many modern systems like chat servers, file sharing applications, and email servers. Can be extended to create a local DNS system for a small organization or a college network. Useful in educational tools to teach how the networks actually send and receive the data. Even the basic web servers, FTP systems, and cloud communication tools are built on this same client server model. So, overall, our project is not just a small academic task, it's a miniature version of how the internet truly works. Moving forward, from this project, we learned how the DNS works in reality, how to use Java for socket programming, how to handle errors, and send data between the computers. Our result, a working model that sends domain names and receives IP addresses successfully. In conclusion, our project successfully demonstrated a small version of the DNS system. It helps us understand the client-server communication, data transfer, and real networking concepts. This experience will help us when building a larger distributed system in the future. Thank you for listening. This is our mini project on the client server name server application, a simple yet powerful example of how the internet really works behind the websites we visit.